Hello, everyone. Thank you so much for joining today's information session where we will be highlighting our astronautical engineering graduate programs. My name is Marilyn Lau, and I'm with the USC Viterbi School of Engineering Admission and Student Engagement team. So it is my pleasure to introduce you to Professor Mike Gruntman, as well as our academic advisor for the Astronautical Engineering Graduate Program, Luis Ceballos. And so both Mike, Professor Gruntman, and Louise will be, taking us through the graduate programs for astronautical engineering. So thank you so much for your participation. So some quick facts, I will be following up in a couple of business days, so you guys will have a copy of today's presentation deck. And for those of you, who are joining us live, please note that the content that we will be discussing today is from October 15th. So we do always recommend for you to visit our website for the most updated information. And in terms of asking questions, we do highly encourage you as well to ask any questions that you might have by popping it into the chat box. And I can go ahead and, answer those questions as they come through, if they are, about the admissions. But no worries, because at the end, we are going to have a Q&A session. So, we could definitely go through any questions as well, if they're for Professor Gruntman, for Louise from the academic side, or admissions and the application process. Today's agenda, we will be going through and talking briefly about University of Southern California for those of you who are not familiar with our academic institution. And then I'll talk about USC Viterbi School of Engineering. And then today's session is highlighting our astronautical engineering programs. I'll introduce you guys to Professor Gruntman. And so he'll be, giving you all a introduction about the astronautical engineering graduate programs. We'll talk about the application criteria. And then I'll go ahead and talk about Dana Viterbi, which is our online delivery method. And, how it is really flexible and practical for those of you as well who may be working professionals. And then we'll go ahead and touch into tuition and funding, and then we'll wrap it up with Q&A. So this slide here is just some images of our campus. So we are located in Los Angeles, really beautiful campus. For those of you, who are in the area, you're always welcome to come by and stop and visit as well. And then a little bit about USC. Oh, okay. Hold on, let me just unmute. Okay, perfect. Okay. So a little bit about USC. So for those of you who are not familiar with USC, so we are located near downtown Los Angeles. We are also the oldest private university in the Western United States, founded back in 1880. We have 23 academic schools and divisions, over 47,000 students, and over 450,000 alumni who are worldwide. We have over 4,700 full-time faculty and a very diverse student population. So our students do come from all different walks of life. So a little bit about our School of Engineering, Viterbi School. So we do have over 6,600 graduate students, over 65 master's programs. But you can see on the slide here that we actually only have 40 of them that are offered through Dana Viterbi, which is our online delivery method. We have over 38 research centers, over 212 full-time tenure track faculty. Our Viterbi School was established in 1905, and we do have over 104,000 Viterbi alumni that are worldwide. Within Viterbi School, we are made up of 8 academic departments. So we have the Aerospace and Mechanical Engineering, Astronautical Engineering, which you guys are here to listen and hear more about and learn more about, the Biomedical Engineering, the Chemical Engineering and Material Science, the Civil and Environmental Engineering department, the Computer Science and Data Science, the Electrical and Computer Engineering department, as well as the Industrial Systems Engineering department. Okay, So, without further ado, all of you are here to learn more about our astronautical engineering graduate programs. So I would love to introduce you guys to Professor Mike Gruntman. He is the program director of the Master of Science in Astronautical Engineering, and he's also a professor of astronautical engineering. He has conducted, research in various areas, including astronautics, spacecraft and space mission design, space physics, space instrumentation and sensors, space plasmas, spacecraft technologies, rocketry, propulsion, and orbital debris. He is also an author and has co-authored more than 300 scholarly publications, including 7 books. So for those of you who are joining us live, when I send out the presentation deck, you will be able to actually click on the links to navigate and read more and learn more about the publications by Professor Gruntman. So very warm welcome, Professor Gruntman. And I will go ahead and let you take us through the next couple of slides.
Thank you very much, and good morning, good afternoon to everybody, wherever you are. So we will be talking about the Department of Astronautical Engineering and our master's program, which is a flagship program of the department, and this is a unique department in the country because typically space in the United States is part of aerospace departments, and the aerospace departments combine aeronautics and astronautics. In our case, we're pure space engineering, pure space department, and this is a unique department in the United States. I will talk briefly about the department, then about faculty, research areas, and then we will focus on the Master of Science degree, which is the topic of today's presentation, today's meeting. We'll talk about students, coursework, criteria for applications, and contact information will be provided. Next, please. So we were established in 2004. As I said, we are in a unique place in the United States because everywhere in the country it's aerospace departments. And why we did it, the rationale, it's a very long story, but there are links here for you to take a look if you want. There's publications in the peer-reviewed journals, presentations in the major international conferences on space about us. But briefly, typical aerospace departments do not view space as a major component. They're still dominated. It's a historical feature. They're still dominated by aeronautical component focused on fluid mechanics, on airplanes and other vehicles flying in the atmosphere. So we are a unique department. We were formally started in 2004, 20 years ago, but we are one of the largest programs in the country in aerospace. And I will a few words a little bit later about that. And we began actually in the early 1990s as a specialization with our aerospace program at USC. So we started in mid-1980s and we built the full-scale program, Bachelor of Science, PhD, Master of Science, Engineer, and all other features of a regular, high-quality research department at a leading research university. Next, please. As I said, we offer all the set of degrees. It's a Bachelor of Science minor, Master of Science, Engineer, PhD, graduate certificate. We have, as I said, we're among the largest national program in aerospace because the national statistics doesn't distinguish space or aeronautics. So in this bigger world of aerospace, we are among the largest. And our student groups that we have some remarkable achievements in building liquid propulsion systems, liquid rocket engines, and also launching rockets, solid rockets that became the highest flying in the world. Our actually students were the first in the world who crossed the von Karman line, 100 kilometers in altitude. So this is the really record. Next, please. We are a relatively small department in terms of full-time faculty, and our full-time faculty is shown on the left. We're like half a dozen people, but and we are growing. And one of our recent additions was Professor Garrett Reisman, who is a former NASA astronaut. So we started to build a human spaceflight component in our teaching program, which is, again, very few universities in the countries do. So we have a very healthy and a small core group. But what is important for the master's program in particular, we have a 2 dozen part-time lecturers and adjunct faculty from the industry and from the government centers, from the space industry and the space government centers like NASA JPL, the Air Forces, Space Forces centers, who teach in our program part-time. They teach specialized courses, and this is what made our program very special, very strong, because our instructors coming from the trenches of the real world, they're top specialists in the leading space companies, large and small, and leading government space centers. So they're at the forefront of the technologies. They know what's happening today in the industry, in the space enterprise, and they teach in our program. It's not only providing the students with this knowledge from the real world, but also this is a unique opportunity for our students to connect to top specialists, which is very important for the finding jobs and for their future careers. So on the right, and you will have this deck of presentation, you will have it to take a look. You see that the people that teach in our program, they're at NASA JPL, at the Boeing, the Aerospace Corporation, Northrop Grumman, and Space Environment Technologies, and many, many others. Next, please. Our department is a typical engineering department in a leading research university in the United States. That means our faculty, we're doing not only teaching, we're doing a lot of research, highly competitive field. We're bringing research grants and contracts. We publish scientific articles. We present results, and many of these articles are together with the students that are engaged. We present results in the leading conferences. We publish books. So some of the books published by the faculty and lecturers are shown here. Next, please. And although we're relatively small in terms of on-campus faculty, we're covering a lot of areas: astronautics, space science, space environment, instrumentation, propulsion, spacecraft design, gases, plasmas, high-performance computing. Our faculty participated in a number of NASA missions on the different level, like mission co-investigators and mission team members, but also uh, outside of NASA in some other government programs with the industry, a lot of interaction. And our work, again, even ended up on the cover of the Science magazine about 10, 15 years ago. And as I mentioned at the bottom, there are the student programs, which are very popular among our students. It's a rocket propulsion lab, liquid propulsion lab, and others. Next, please. We collaborate, again, as in any leading research university. Our faculty is internationally recognized, accomplished. We collaborate with different departments here on campus, but also we have a very broad external collaboration with other universities in the United States, other government centers like NASA centers, Department of Energy centers, a lot of other research institutions, and with many places in industry and in the foreign countries. Next, please. The degree that we are talking about in astronautical engineering, it's a highly dynamic degree. Technology evolves and the space enterprise evolves, and it's a very advanced area of technology. The program designed for those with the Bachelor of Science degree in Science and Engineering. So this is very important. We do not require a Bachelor of Science degree in aerospace engineering. And this is a very different from most of other programs in the country. So if you want to get a master's degree specializing in some space technology, you have to go to aerospace department and they will take you if you have a Bachelor of Science in Aerospace Engineering. We don't require that. A Bachelor of Science degree in physics, mathematics, chemistry, and in any area of engineering is sufficient. You come to us, and we have actually a special class. It's an introductory class on the space systems, which serves as a boot camp for students from all other specialties. And after that, you can go to any specialized course and take it. And this approach reflects what happens in the space industry, because space industry, and when I say space industry, I also mean government centers here. The space industry employs engineers of all possible flavors: chemical, computer, structural, civil engineering, electrical, you name it. And these engineers work very successfully in the space industry. And when they want to grow further to the position of technical leadership, to become, say, a system engineer of the major space system or spacecraft or a space mission, they cannot get there in these positions because they lack specialized space education. So this is where our program comes in. We will take, regardless of your background, as long as it is in hard sciences and engineering, we'll take you to our program. And after our program, you're sort of well qualified to move further and advance to the high positions in the technology. We combine science and engineering fundamentals with specialized courses. And as I said, specialized courses are taught by the top experts from the space industry and government centers who are today very, very active. And at the bottom, there's a list of some companies where our part-time lecturers and adjunct faculty work. And again, these are all the top legacy companies in the country: aerospace defense companies and the government centers, and the small highly visible companies are here as well. Next, please. Our students, about one half of our students are full-time on-campus students, regular students, but simultaneously every class that we offer has students in the classroom, but simultaneously is being webcast to our online students. And one half of our students, or one half of our degrees that we award, goes to the online students. The same classes, the same coursework. And as you will, Marilyn will talk to you a little bit later about that, it's exactly the same requirements, the same quality. So no difference whatsoever between the degree for a student online and offline in all aspects. So it's a 50-50 roughly break. We have students work, these online students, they work full time in the leading companies, large and small. They work in government centers, some of them on active duty military, serving in our different branches of the armed service. And the background of our students, because we take students with all the possible flavors of engineering and science degrees, astronautics, mechanical, electrical, aerospace, chemical, computer, physics, astronomy. We even have a medical doctors. Every, say, 2 years, a medical doctor joins our program. He or she wants to become an astronaut, and our program really helps them to beef up their credential. Next slide, please. On the left, you can see the map of the United States, our online students coming from all over the country. So wherever there's a space activities, we have our students. We have students from Canada, and also some students overseas. It's typically active duty military when they're stationed just far away. On the right is the program dynamics. When we started in 2004, the number of the degrees that we award, Master of Science degrees, and we awarded more than 1,000 degrees during the last 20 years. We're one of the largest aerospace programs in the country. When I'm saying aerospace, I mean that there's no national statistics for space engineering, only for the combined area of aeronautics and astronautics, and aeronautics is much bigger than astronautics. So in spite of that, we account for from 3 to 5% of the national Master of Science degrees. So this is a very large contribution. And during the last 5 or 6 years, we have been awarding more than 80 degrees each year. Next slide, please. We have also a big community of our alumni. We have, for example, a group on the LinkedIn, which is 700 members these days. It's still growing. And this is the community of our alumni. Please, next slide. Okay. Admission requirements, as we already said, it's you have to have a Bachelor of Science degree in Engineering or Science, no degree in aerospace required. There's a minimum cumulative grade point average 3 on a 4.0 scale. If your GPA is less than that, still there are ways to get into the program if you show commitment and motivation. Again, Louis or we can just explain you in the detail offline later what needs to be done. GREs were usually needed, now they're suspended after the COVID, and 2 letters of recommendation. So you're getting in our program, what do you have to do to get a degree? 4 required courses, absolutely essential key courses: spacecraft system design, it's an overview of space systems, a course on space environment, on rocket propulsion, and on orbital mechanics. Then there are 3 courses that are required. They are core elective courses, and you choose them from a list of more than a dozen of courses that we offer in astronautics. And again, most of them are taught by our top specialists in industry, our adjunct faculty. And in addition to these elective courses, 2 more technical electives are needed, and the technical electives are typically taken from the same list of core elective courses, but can be taken from other department if you want. For your educational objectives, you want to have a course in integrated circuitry or in artificial intelligence or whatever, biomedical things, whatever is needed, you can take it, it's no problem at all. But most students take these elective courses from the list of core electives that we offer, because the breadth of these core elective courses is among the most important reasons why students come to our program, and we're highly competitive on that. Master of Science thesis is optional. Very few students choose this option. It's possible. And the reason that very few are taking this option, because a thesis requires very significant effort, much bigger than to take the coursework for the same number of units for credit. And also many students want to take advantage of the offered courses, because again, this is the reason why they came to the program, the breadth of courses that they could be exposed to. And also at the bottom left shows the liquid propulsion laboratory activities. That's a student program that is primarily populated by our master students, typically 50 or 60 master students engaged every year in this program. In this student group, they design, build, and test very sophisticated liquid propellant engines. Next slide, please. So this slide shows the courses that today currently available. They are color-coded for different areas of specialization. It starts at the top left, courses focusing on satellite systems. Then the next group in a bluish color, dark bluish color, is spacecraft dynamics. It's orbital mechanics, navigation, solar system navigations, attitude dynamics. Then at the bottom left, there are red color-coded courses that are linked to the propulsion areas. And we, in addition to introductory course in rocket and spacecraft propulsion, we have a liquid propulsion course, solid propulsion, advanced spacecraft propulsion, which is basically electric propulsion, space launch vehicle design, physical gas dynamics, and others. And then there are courses on the dynamics of the satellites. Then the set of group of courses on various satellite subsystems, sensors, remote sensing, power systems, thermal control. And on the right, in the right column on the top, there is a new emerging areas. We offer 3 courses in space safety, which is rapidly growing area, emerging area, very important because the space activities are exploding, including human space flight. So it's becoming more and more important. So we're on this cutting edge, offering the coursework in this area. Then as I mentioned, we have an astronaut who joined our program as a faculty. So he has been developing a cluster of courses on human space flight. We already have 3 courses in this area. And then we have some highly specialized courses in plasma dynamics, computational plasma dynamics, and so on. Next slide, please. A common question, just to preempt a few questions that you may have. So how much time does it take for students to complete the program? If you are a full-time student, it's typically 3 semesters. A total of 9 courses. A typical load for a full-time student is 3 courses per semester. So you need 3 semesters. And in addition, students engaged in the, say, liquid propulsion laboratory or in some other research activities. Now, sometimes this stay at the university becomes a little bit longer, and the reason is many students pursue internships, full-time students pursue internships when they study, and there are a lot of local opportunities. Obviously, there are government centers like the NASA or the Aerospace Corporation, but we are very close geographically to SpaceX, and historically SpaceX at Hawthorne, where they started, took a huge number of our students, undergraduate and graduate students, as interns, and the students go to internship. They like what they're doing, and they're being liked because it's our rocket scientist students. It's a high quality students. So SpaceX and other companies like them, they extend their internship during the regular semester. Students had to decrease the number of courses that they take each semester. So this 1.5 year may become 2 years. It happens just all the time. For part-time students, it's typically 4 years, because if you work full-time and study part-time, a typical load is 1 course per semester, occasionally maybe 2 courses per semester. A total you need of 9 courses, so it takes 4 years. And then required sequence of courses. Do we require, say, required courses before electives? And the answer is no. It is entirely up to student to choose the selection of the courses. And but typically students begin with the required courses. The required courses really is the foundation on which everything else is being built. So the students begin with the required courses, but they don't have to. And we as advisors, when we advise students, we're here to help a student to adjust the sequence of courses to take to a particular situation, to a particular background. Because depending on the background of a student, is particularly on the Bachelor of Science background, some courses may present more challenge, others may present a less challenge. So for example, if your background is electrical engineering, a course in propulsion may be more difficult for you because it's gas dynamics involved. And the last time a student with the Bachelor of Science in Electrical Engineering heard about gases was in the freshman or sophomore physics, and never again. So it depends on the situation. We're here to help to figure out the right way to proceed. Waiver of required courses. So sometimes during the undergraduate years, students took a course that is of the overlapping content with the required course. For example, a senior course in propulsion from an aerospace department would overlap with our required course in the rocket and spacecraft propulsion. There's no need to repeat the coursework, waste your time, our time. It's better. We will waive this requirement. It's almost automatically done. Very easy process, 5 minutes takes. We waive this requirement. And instead of this required course, it opens you a possibility to take an additional technical elective course. And again, this breadth of technical elective courses that we offer is one of the main reasons why students come to our program. Can you take a technical elective from another department? Yes, absolutely. 2 technical electives. We will approve a technical elective course from basically from any other science, hard science and engineering department. So if for your educational objectives, you want to get a course exposure in error correcting codes for communications, artificial intelligence, combustion, or any of vibrations of structures, anything is possible. So no problem at all to approve that. As I mentioned, our full-time working students very often they are very successful in the space industry, but their background is not space related. And in order to move to the systems engineering positions and become in the positions of the technical leadership of the major space systems or subsystems, they need some space background. They come to our program, so it opens a pathway to systems engineering position and to the position in technical leadership in general in the space industry. Attending classes on campus by online students. It's very welcome. It happens all the time. Our online students come to Los Angeles on business or for some other reasons. They, without any special permissions, so they just come to campus and join the live classes. They interact with the faculty to say hi, to meet in person the faculty member with whom they interact usually over online. In addition, so distance education, and Marilyn will be talking about that, is a very important and powerful tool that we have. All lectures, when they deliver, they're recorded for the students and they go to the university server, and all students on campus or online have access to these lectures until the end of the semester as many times as they want. And this is a very important because sometimes material presents difficulties. So a student can go multiple times and listen to this 10-minute part of the lecture where they have difficulties to understand the material. So it's a very, very helpful. But in addition, sometimes students are engaged in different activities on campus, so they can skip a lecture, live lecture, and then next day watch it at their convenience whenever it's whenever they can do this. So it's a very, very helpful to properly organize your time most efficiently. And this is one of the main features that in your professional lives you will have to do. You have to manage your time and to use it as efficiently as possible. And as far as very often the question comes about the difference between astronautical engineering and aerospace engineering. We don't have time here to discuss. I can only point you to the publication which is here that discusses in detail. But again, the space became so specialized that the typical aerospace degree does not provide enough background in space. If you want to be in the space industry, it became so big and so specialized that you really need to start studying from the very beginning. And next slide, please. And this is concludes my part. These are the contact numbers. We have the Luis is which is a head of our student services. He's here. His contact information, my contact information, so you can reach us anytime you need. There's again link to a publication, and there's a link to Marilyn also on the general questions about our distance programs and just how and what to do. And a limited student that is mentioned here on the right box next to Marilyn, it's very important. If you want to join the program and your undergraduate GPA is 3.0 or higher, you don't need to be admitted to the program to start taking classes. You can start taking classes very quickly. It takes a few days to get an approval. And then after that, while you are taking classes, you submit a regular application, because a typical application takes half a year just to go through all the hoops, but you can start studying very quickly. How to do it? This magic, Marilyn would know how to do this. All right, so this is, I'm handing it over to you, and we can go from here.
Thank you so much, Professor Gruntman, for all of that information. And it is, a great segue as well into, kind of what I'll talk about next. So Professor Gruntman did talk about this in the previous slide. So one thing that I'm just going to talk about is the application deadlines. So for those of you who are interested in applying for spring 2026, which begins in January, an application extension can be possible on a case-by-case basis for online Dana Viterbi students, as long as you do not require a student visa sponsorship. So that deadline is November 14th. So you could email me at dana@viterbi.usc.edu for more information on this extension. And for those of you who are interested in applying for fall 2026 for formal admissions, the department application deadline specifically for the astronautical engineering programs is February 15th. And once again, for our online Dana Viterbi students, as well as our military students, we do offer application extensions as well beyond the dates that you guys do see on the website. So please reach out to me at danaviterbi.usc.edu, and I can provide you more information on that extension. And as Professor Gruntman, touched upon, if you do want to begin classes as soon as possible in spring semester, but you don't have the time, or the bandwidth to even put together a formal application, and you do meet the eligibility requirements of our limited status enrollment, you can begin by taking a class in spring. And more information can be found on the link below, but I will be touching upon talking about limited status in a couple of slides within the presentation. So in terms of the delivery methods, so as a graduate student at USC Viterbi, we have two delivery modalities. The first, as Professor Gruntman mentioned, is on campus, which is when students tend to, study full time, and then online through Dana Viterbi, where typically most of our students, around 80–85% of them, are working professionals. So they do pursue their degree part time, but then we do still have some students, who are full-time, studying full-time, but from a distance, so they're not based in Los Angeles. So let's talk now about how does our online delivery method work. So our online delivery method is it is in-house, and we started doing distance education learning since 1972. So we're kind of the pioneers in distance education learning, and essentially, as of today, it is our in-house proprietary web-based delivery system. And it really enables our students from all over the world to access classes in two ways. So you could watch it live as it's happening by streaming in, or you could watch it on demand afterwards as a recording on your own time. So for those of you, who are working full time, we do understand, working, 8+ hours a day, plus any kind of, personal commitments that you might have afterwards, you might not be able to stream in and attend lectures live as it's happening. But no worries, there is a recording that you can access afterwards on your own time. And as Professor Gruntman touched upon, DEN students, are more than welcome to sit in on lectures in person. And the reason behind that is, because every DEN of a Viterbi student does have a physical seat in every class that they are enrolled in. So if you work in the LA area, you're more than welcome, to come down and attend lectures, but if you, are traveling down here for business or taking personal trips out here, you are welcome to attend lectures in person, but it's not a requirement at all to come to campus. And so all Dana Viterbi students still view the same lectures as on-campus student. So the content is fresh every semester. You will still participate in highly interactive discussions with the professors and your peers. And you will still submit homework, but you would do it electronically. So as a DEN student, you still have that interactivity. You will be required, though, to take your exams at a proctor testing center, either located near your home or your work. For those of you who are in the LA, Orange, or Ventura counties, you would be required to take your exams at USC's campus. So this kind of in-person element, is the reason as well why your degree that you will be earning is the same as a on-campus student. So this slide here just kind of gives you a bit of a comparison because, you might be wondering, what's the difference between a DEN student versus on-campus student? You may be currently undecided. You're like, both options sounds good. I just want to learn a little bit more. So as you can see, the program admissions is the same for both of the delivery modalities. You are still required to submit a graduate application and the required materials. The weekly course lectures is online with interactivity for DEN students. On-campus students will be attending lectures on campus. Online course archives, such as having access to lectures and course documents, as Professor Gruntman talked about. All DNV students do have access to this. On-campus students have access to this as well, as long as they are enrolled in a class that is offered online through DEN. Assignments will be submitted electronically, but the course deadline dates will be the same as on-campus students. Exams will be at a proctored location unless you are residing in the LA, Orange, or Ventura counties. Courses per semester is between 1 to 2 if you are a DNV student and working full-time. Yes, Professor Grimmett.
I just would like to bring some additional clarification about the exams. After
Yes.
the COVID, many classes conduct exams electronically. That means you even don't need, regardless where you are, whether you're online student or you're on-campus students, you don't need even to come to the classroom or special centers. You just do it from your home, office, or whatever location is convenient. You basically download PDF, you do the exam, when the window opens, you download PDF with the exam, you do the solutions, and you scan within the allocated time, 2 hours, 3 hours, whatever is for this particular exam. You scan your solutions and upload. So it can be done from home. So it's many classes use also this modality these days. So it's becoming even more convenient. So, sorry for this
Thank you so
additional
much
detail.
for clarifying that. Yeah, thank you so much
Mhm,
for clarifying.
mhm.
So that's good to know. And so it definitely would be good. I guess it's kind of like up to like the professor's kind of
Correct.
discretion, right?
Correct.
Perfect. Thank you for clarifying that. So that is good to know because it offers a lot more flexibility as well. And so in terms of the degree completion requirements, as discussed as well, you do need to have at least a 3.0 GPA or above, and you do need to complete between 27 to 37 units of approved coursework. So ultimately, when you do complete your degree, your diploma is going to be the same. There is no distinction on there that you are an online student or an on-campus student. So we do get a lot of people do ask that questions. And so, it is good to know that there is no difference because it is the same degree that you are earning. It is just the delivery modality is different. Some additional information about our online delivery method, Dana is limited status. So we briefly touched upon this. So it is a enrollment option that allows strong candidates to who have a undergraduate degree in engineering, math, or hard science from a regionally accredited academic institution. And you do need to have the minimum of a 3.0 cumulative GPA. And if you meet these eligibility requirements, you can begin coursework before submitting your application for formal admissions. However, you can only take a maximum of 12 units. And so if you are then admitted into the astronautical engineering master's program afterwards, and those classes that you took as a limited status student, it can be transferred over to that program upon the department's approval. And it's also important to note that being a limited status also doesn't guarantee formal admission. So you do still need to submit your formal application. And so if you guys want to get started as early as spring 2026, which begins January of next year, you can head over and learn more about our limited status enrollment details. And then also I do host limited status webinars starting November and December. And for those of you who may be, supported financially, reimbursed by your employer, we do have the Employer Reimbursement Deferment Program. And so this is for students who are supported by a company. You can defer your payment of up to 90% of tuition until after the semester is over. Program eligibility is that your student account has to be current, which means that there is no outstanding balance, and your employer has to reimburse you for tuition at the end of each term. So you as a student, there are some requirements that you do need to handle. More of the admin task before the settlement deadline of each term is to complete and submit your deferment application, pay 10% of tuition, 100% of all fees, and a $100 application fee, and sign and submit your promissory note packet and send it to our colleagues at USC, sfs@usc.edu. For more information about employer reimbursement, how it works, details, you can find more of that information on our link indicated on the slide below. So this slide here just highlights our current tuition rates for the Viterbi Graduate Engineering Computer Science. So this is for this current academic year. And you can kind of see how much a per unit rate is, a 3-unit course and a 4-unit course. So our tuition is calculated every semester based off of how many units you take. So one class can vary between 3 to 4 units, for example. The tuition is the same as well for both online and on-campus students, and it is also subject to change without notice. So we always recommend, when you're ready to submit your application, to always head over to our website and reference the tuition page just to see what the most updated and current tuition rates are for the current academic year that you will be applying to. So with that said, we do have some scholarships as well to help with the assistance of being an online Dana Viterbi student. So our Dana Viterbi scholarship is a merit-based scholarship, and it is awarded to outstanding students who are pursuing a master's program fully online through Dana Viterbi. So the scholarship details is, first and foremost, it is a partial scholarship. So it's not full. If you are awarded, you can receive, though, up to 1 to 4 units of tuition. You must be pursuing a Viterbi master's program fully online and also receive partial or no tuition reimbursement funds from your employer. The funding will be provided within the academic year. You can only be awarded once per academic year. However, you can reapply again for a future academic year. So just for context, if you apply for fall 2026 and you are awarded, you can use your awarded units to either fall or spring. If you use it in fall, you won't be eligible to apply in spring, but you could reapply again for the future academic year. To be eligible, you have to be either a newly admitted student or have an admissions application on file. And you must have an undergraduate degree with a minimum cumulative GPA of at least a 3.0 on a 4.0 scale. So the spring 2026 scholarship deadline for the Dana Viterbi scholarship consideration is Friday, November 14th. And for those of you who are interested in fall 2026, the deadline date will be posted on the website after the spring 2026 date has concluded. And you can actually find more information about the scholarship as well as the application form itself on our website at the link below. And for those of you who may be U.S. active duty military or veteran, we do have some funding and scholarships available as well. We offer the USC Viterbi Active Duty Military Scholarship. So this is a partial scholarship, and it ranges from between $5,000 to $20,000 of tuition for U.S. active duty military of all military branches. And you could be pursuing a Viterbi Master's or a graduate certificate program, and it could be online or on USC's campus. And also receive partial or no tuition reimbursement funds from the military or your employer. The spring 2026 scholarship deadline is also on Friday, November 14th, and the fall 2026 deadline date will be posted on the website after the spring date has passed. In addition, we do offer yellow ribbon funding. So USC Viterbi offers an unlimited number of yellow ribbon awards To eligible veteran candidates who are entitled to the 100% post 9/11 benefit rate. Max is at $10,000 a year, and the VA will also match the amount that is provided by USC Viterbi. And for those of you who are veterans, we do have the USC Show and Family Scholarship for Veterans. So this is for Viterbi incoming and continuing graduate students. You are eligible to apply. You must, though, be admitted and enrolled immediately in courses on a full-time basis, which is 8 units or more. And you must have received an honorable discharge from the U.S. Armed Forces and served a minimum of 3 years, being continuous full-time active duty since 2003. And for more information as well, you can head over to our military page on our website. So this slide here is to help you guys get started. So if you're looking for a one slider to kind of help you navigate in submitting your application, starting your application, this is a one to refer to. If you are also interested in getting started as a limited status student, you can head over to the link below and complete your limited status request form for spring 2026. Okay, so it is time for Q&A. So let's see. I saw some questions that came through. So we'll go ahead and go through them. So the first one is, are courses designed with opportunities for real-world projects, such as designing, manufacturing, launching a CubeSat for a satellite design course? Or are these opportunities mainly relegated to SERC or LPL?
So, so the answer is that most of the coursework has a limited amount of hands-on projects and interactions because most of the students, not most, one half of the students are online, and it's the courses should serve everybody. Having said that, we have a few courses that specifically involve interaction and hands-on. One of them is so-called Space Studio Architecting, and another one is spacecraft communications, where the students, it's a limited enrollment, about 12, 14 students for each semester. Half of the students on campus, half of the students online, and they work even online, they remotely. I engaged in capturing communications from satellites by an antenna that is on the roof of one of our buildings on campus here. So there's some activities there, but most of the hands-on activities with particularly with the CubeSats or everything like that, it's necessary to be a full-time on-campus student and get engaged in the projects either in SERC, this SERC, SERC, Space Engineering Research Center, which is partially owned by the department, by our program, and its director, Professor Barnhart, is a faculty member in our group, in our department, and or in other groups like Liquid Propulsion Laboratory or Rocket Propulsion Laboratory. Or in the individual grants and contracts that are being directed by the faculty members who are part of the department. Again, we have half a dozen faculty members, and they have their research grants and contracts. But these are very advanced, usually very advanced activities, primarily for doctoral students, but some opportunities for Masters of Science students also exist. In contrast, SERC, Space Engineering and Research Center, engages a large number of master students as well.
Thank you, Professor. So a follow-up question for that is, what is the process of joining a lab such as SERC or LPL? And is there a specific process?
So yes, there are specific processes for with the LPL. Each semester, students simply send an application, because this LPL is a student-run group. It's run by the self-selected leaders that emerge from the activities. Typically, 2 students lead this effort each year. So every semester, students send applications, and it's very easy actually to get to LPL, because The only real condition is there should be real commitment. A student cannot spend 1 hour each week only because building anything for the real world requires many contributions from many members of the team. And if you do not deliver what you have to deliver, then it will stop work for many other members of the team. Therefore, there should be some real commitment, and many students spend a lot of time. I can tell you in LPL, they're so excited. 50 or 60 students are engaged every year working on various subsystems, and then the tests, obviously, in the desert. As far as CERC is concerned, it's the way is to simply contact the director of CERC, and he juggles the projects that are on his plate, on the plate of the CERC. He juggles the projects, demands from the resources, financial resources, and it must be done on an individual basis. The same with the projects of individual faculty. It's necessary to contact individual faculties.
Mhm. Thank you, Professor. So question is, for Dana Viterbi students, are research opportunities available?
This is again individually. Oh, for Dan,
For Dan, yeah, for Dan. For
for
the,
then
yeah.
students opportunities are very limited because it's all research is conducted by under some guidance of faculty. And if a faculty member who has some grant or contract with a government agency or with the industrial company feels that the then student could contribute, it's possible, but it is highly unlikely because participation in the research projects really requires face-to-face interaction and a significant time commitment. Again, it's possible on the individual basis. It's necessary to establish such a work, but it is not very easy to do. So I would, if I were a then student, I would concentrate on taking as much as possible from the unique coursework that is being offered by the program.
Thank you. So a question that came through is, are courses offered during the summer to accelerate time of graduation?
A short answer is yes, but it's conditional number. The number of courses is very small. Typically, we offer 1 or 2 courses during the summer. Graduate courses. Actually, one required course in orbital mechanics has been offered during the last several years, every summer. Occasionally, spacecraft attitude control. This forthcoming summer, there will be liquid propulsion will be offered, but again, it's typically 1 or 2 courses, not that many. A
Mhm.
careful planning is needed if you want to accelerate. A careful planning would be needed how to navigate that, but the program maintains a long-term class schedule. I would say tentative class schedule because at the last moment there could be some cancellations. It does happen because again we do not control everything. We have the dean's office that is the final decider, and also sometimes our instructors may develop a very significant scheduling conflicts. It may be work related or maybe personal because things do happen in lives. They're also humans, our instructors, and the things do happen in their lives as well.
Yeah. Thank you so much, Professor Grutman. Okay, I don't see any additional questions that have come through. Oh, here we go. Okay. I understand it may vary per person, although can you share what are some types of jobs that students who finish the program typically tend to follow? Or is it pretty diverse?
I, the answer is pretty diverse, but we have every parts of the space enterprise are here. We have the students who go to legacy companies, that means the big aerospace defense companies, Northrop Grumman, Boeing, Lockheed Martin. They go to the government, NASA centers, Space Force, or in the past Air Force centers, the Aerospace Corporation. There's some go to other parts in the Defense Department and intelligence community. We have students that go to work to the smaller companies because the space industry, as aerospace industry in general, has been evolving during the last few decades, and a lot of advanced research and development has transitioned into the second tier contractors. From that means from the Northrop Grumman's and Boeing's and Lockheed's to smaller companies that concentrate on various subsystems. A lot of work is being done there, and also startups. A number of our students are engaged in the startups. Actually, some of the students who graduated from the program, they are running space companies and rocket companies that are on the radar screen, and becoming now actually getting some major programs. And so it's a lot of opportunities. It's very diverse combination of various jobs that students go to.
Mhm. Yeah, thank you, Professor Gruntman. And just to kind of write on that as well. So we do. So Viterbi does have a career connections team for those of you who are interested about whether or not there are career services that are there to help with job opportunities. So we do have a career connections team that works with our master's students, and both on campus and then as well. And so yeah, you do have access to the career connections, and they could help with like internships, job opportunities. They host career fairs throughout the year as well. So definitely, we do have that support available, and resource available for master students. Um, okay. Okay, so I don't see any additional questions. So thank you so much, Professor Grumman and Louise, for taking the time in, talking about the astronautical engineering graduate programs. And for those of you who are joining us live, hope you really found it informative. And for those of you watching as a recording later on, if you guys have any questions, you could always, let me just go back to this page. Yeah, you could always, reach out to Professor Gruntman, or Louise about like the program itself, the academics. And if you have any questions about the application process, limited status, being a Dent student, please go ahead and contact me. So thank you everyone for attending today's session. Any last words, Professor Gruntman, or Louise, before we wrap this up?
We should go to the stars, all of us, and to the moon. I'm actually from the moon now. No, we will welcome all the bright people who want to go to space. And again, I would say that our students are truly highly motivated, and the space enterprise, global space enterprise, not, last several years and now just growing, especially on the commercial side. Government is very stable, and but on the commercial side growing very fast. On the government side, there is some issues at NASA, but on the national security side, there is a major advancement, in particular with the recent initiatives in Washington, in the missile defense and other areas. So it's again, space is growing, it's very healthy, and everybody looks for good people. And again, our students are typically very motivated, with bright, wide eyes, looking at the stars, and we will help you to get there as much as we can.
Perfect. Thank you. Thank you, Professor Grotman. Thank you, Louise. So yeah, take care, everyone. I will be following up in a couple of business days. Stay safe. And as we say at USC, fight on.
All right.